What's up, everyone? Today we are going to be multiplying binomials, which I am super excited about. I just love talking about this unit. So, to multiply two binomials, oh, that did not turn out to be good. What is it? Multiply two binomials, you must distribute each term of the first binomial to each term of the second binomial. So here we're just using the distributive property. Then you are going to combine like terms. So your algebra teacher, or your pre-algebra teacher, or your tutor, or whoever may have taught you the following. You may have learned this acronym FOIL, which stands for first, out, outer, inside, and last. So what that does is it's an acronym that teaches you how to multiply binomials. It works every single time, but only for binomials. So the issue is, it'll work for all these problems here, but then once we move on and we are talking about something a little bit more sophisticated, maybe you've got a binomial times something larger, like a trinomial, suddenly here there's two terms, but here there's three terms, and I don't know, this acronym doesn't teach me how to expand or multiply those guys. And so that's why most of the time you'll hear me talking about distributing or expanding, not so much using that acronym FOIL, just because I want to teach you something conceptual that's always going to work and not something that's like a quick hack for getting through a couple of problems, but then you can't bring it on with you into the future. Oh, that's so funny. Goodness is telling you that I misspelled multiply earlier, got aggressive, and I crossed my L. That's so silly. Oh, wow. Alrighty, so how does this work? Well, what we're going to do is each term in the first binomial needs multiplied by each term in the second binomial. And so how I like to show this is both the color coding, of course, always, and then also I like to draw arrows. So this 2x needs to get multiplied by this x, and then it needs to also get multiplied by this 4. Okay, so you can write those as separate steps, but like with parentheses and then multiply them together. But since we practice distributing a monomial, which is all of this that we're doing right now, right? 2x, think about it like it's monomial, that we are just distributing into x plus 4. We don't need to, because we already practiced that, we're just going to jump straight here and multiplying it by like in our head. So 2x times x, that's going to be 2x squared. 2x times 4, that's going to be plus 8x. Alright, now I'm going to switch colors here. I'm going to take 3 and I'm going to distribute that into this binomial x plus 4. So I've got here plus 3x plus 12. Alright, now notice how we have 8x and 3x here. So I only have one x squared term, I only have one constant term, and 12. But here I have two linear terms here in the middle that just have x to that first power. So I can combine those like terms together, and I'm going to end up with 2x squared plus 11x plus 1. There we have it. That right there is the product, right? The answer to a multiplication problem of 2x plus 3 and x plus 4. Alright, let's look at this next one here. 5x plus 1 times 8x minus 2. So again, we're going to take 5x and we're going to distribute it. So 5x times 8x is 40x squared. 5x minus 2, that would be minus 10x. We're going to switch colors and we distribute the 1. That means we'll just end up with the second binomial as it appears, right? 8x plus 2. And then again, we have these middle terms here that we're going to have to add together. So we'll have 40x squared. Then we'll have minus 10 plus 8. So that's going to be minus 2x minus 2. All right, now that having to add together that middle term is going to happen every single time when you have a linear binomial times a linear binomial and they're both in standard form. Then you'll always end up with this quadratic term, two linear terms, and a constant term, and then be able to add those two linear terms together in the middle. If I'm saying these things like monomial, binomial, constant, linear, quadratic, and you're like, I don't know what this lady's talking about, go back and watch our video on adding, subtracting, and classifying polynomials. That last part, the classifying or naming the polynomials, is going to help with some of that vocabulary surrounding this unit. Make sure you go back and you watch that one if you haven't already. Alrighty, so example two. Keep on moving and grooving here. X times x times negative 3, so it'll be x squared minus 3x. We have to distribute minus 1, so every time it's going to be the opposite. We'll have minus x plus 3. And that combine these like terms right here in the middle. X squared yes, 4x plus minus x times 3x, x times 4, 3x squared plus 4x. There's 3 times 3x, that's going to be plus 9x. 3 times 4, 3 plus 12. And now we've got 4x, 9x, putting that together, so 3x squared, 13x plus 12. Alright, last one on this page, we've got x times 4x, x times negative 2, 4x squared minus 2x plus 24x minus 12. And those middle terms there, 4x squared, 22x minus 12. All right, there you go. So now on the back here, table 3, I want you to go ahead and try these out, okay? So I'm just going to give you a hint. Some cool stuff is going to happen in the last two. So I want you to check them out, see what you can do. I'll give you a little hint. Rewrite this one as x minus 4 times x minus 4. Don't let that little square scare you, right? All squaring means is that you're taking something and multiplying it by itself one time. So here we have x minus 4, and I'm going to multiply it by itself, x minus 4. And then we're going to see what happens there. So go ahead, pause the video. Alrighty, so here we go. We got x minus 7 times 5x plus 1. So I'm all distributing. We'll end up with 5x squared plus x minus 35x minus 7, 5x squared minus 34x, when you combine this like terms, minus 7. That was boring one. Hold on, let's fix that. There you go. Alright, so what I have going on here. We've got one of the first of our two exciting ones. So we're going to have x times x times 2, negative 2 times x, negative 2 times 2. So we'll get x squared plus 2x minus 2x minus 4. All right, so what do you notice here? Well, these two terms here, those middle terms are usually combined together, they're identical except one's positive and one's negative, which means that they make a zero pair. They cancel out. So we're left with x squared minus 4. So this thing that we just saw here actually is part of a larger pattern. So in math, we do a lot of recognizing patterns, right? And so this is what's known as a special multiplying or like multiplication pattern or special factoring pattern, which we talked about um, um, with taking out the GCF the other day. But it's the inverse of distributing. This is our first special pattern, and it's called the difference of squares, or you might hear it called difference of two squares. I'm going to show you the pattern here for the squares. So I have some a minus b times a plus b. So notice that's what we had going on here. Add x minus 2 and x plus 2. So those look nearly identical, except the signs in the middle were opposite, right? One was positive and one was negative. So every time you have a multiplication problem that looks like that, where you have something minus something else, right, times that same something plus that same something else, it's going to look like whatever that first thing is squared minus whatever that second thing is squared. Because every single time what happens is when you expand this, here, I'll do it really quick and then I'll erase it. If I were to expand this, right, I'd have a squared plus ab, and then I'd have minus ab minus b squared, and those will cancel every single time, leaving you just with that a squared minus the b squared. It'll happen every single time. So it's super helpful, not only from the multiplying perspective, right, from being able to say, oh, I have a minus b times a plus b. Now I can rewrite that as a squared minus b squared, but also when we start learning about the reverse and we start taking things from standard form and learn them, write them as these multiplication problems in this factored form on the left hand side, we can do that much easier as well, which is really exciting. All right, next I started you off with a hint here. I said, all right, go ahead and rewrite it as binomial times another binomial. So you can do draw your arrows, the double stroke idea, and we want to know what's going to happen here. So here, I'm going to end up with x squared minus 4x minus 4x again plus 16. So this time we end up exactly the same two middle terms here. So we've got minus 4x and another minus 4x. They have the same sign, so they don't cancel each other out. But instead, we end up kind of with that duplicate. So we have x squared minus 8x plus 16 as our final answer. So you may know the setup for this one looks very similar to the last problem, except instead of our signs being opposite, right, having one that's negative and one that's positive, we have the same signs. These are perfectly identical, right? X minus or quantity squared. We're multiplying something by itself in this case. So this is our second special multiplication pattern or special factoring pattern, and this is called the perfect square trinomial, because in math we're not really creative when we name things. Like I'm always saying, we tell it like it is. And so a perfect square, right, is just a number that is, well, a perfect square. Like 4, 16, 36, right, so on and so forth, right? These are perfect squares. And so um, this trinomial that we got as a result, it's also a perfect square. It doesn't look like it. It might not be one that you have memorized, right? Like 81, for example. But this is the result of taking one factor here, that x minus 4, and multiplying it by itself or squaring it. So pretty cool here. So there's going to be two different kind of options here depending on if the sign in between our two terms in our binomial is positive or if it's negative. So if it's positive, a plus b 1 squared will expand to a squared plus 2ab, because we all end up with two of the same middle term, plus b squared. Now this b squared is always going to be positive, because no matter if it was plus b or if it was minus b in the equation, they've got the same, or in the original binomial, we've got the same sign being multiplied by itself. That always results in a positive number. And then whatever sign this is here, it always matches whatever was in the binomial, because those are always the same. These two signs are always going to be the same. I'll turn this into arrows. It's confusing. And this one here is always positive. Always positive, and then here I'll just put 6. Now, if it's negative, it's a minus b. That would look like a 3 minus 2ab. Again, always same sign here. Those are your two bonus nuggets in here of the special multiplication pattern and multiplying binomials.